ultra-RAM scaled for volume production. Memory that promises DRAM-like speeds. 4,000 times the durability of the NAND, and the data retention for up to 1,000 years, and is now ready for manufacturing. At the heart of the breakthrough is an advanced industrial process using a gallium antimonide and aluminum antimonide epitaxy. Okay, the effort to commercialize the ultra-RAM have made a significant stride forward. QNAS Technology, the firm behind the ultra-RAM, has been busy working alongside advanced wafer product makers IQE PLC for the last years to scale the ultra-RAM memory devices creation into an industrial process. According to the blocks and files, the collaboration has been a success. The memory that promises DRAM-like speeds, 4,000 times the durability and NAND, and the data retention for up to 1,000 years is now on the cusp of the production. The design now benefits from the development of a new and advanced gallium antimonide and aluminum antimonide epitaxy process claimed to a world first, which will enable ultra-RAM as a volume production. Ultra-RAM is reliant on the epitaxy process, where the compound semiconductor layers are grown with a great precision on the crystalline substrate. Later, more familiar semiconductor production processes, and such as photolithography and etching, and then the applied to create a memory chip structure. We have successfully achieved our goal of developing a scalable epitaxy process for ultra-RAM, a milestone toward industrial production of the packaged chips. Jutta Meyer, CEO of IQE, said in a statement produced by the blogging file, "This project represents a unique opportunity to bring the next generation of compound semiconductor materials to life in the UK." The complimentary statement from the QNAS CEO and founder James Ashford-Pook characterized the collaborative success as a turning point in the journey from the university research to commercial memory product. Next up on the commercialized roadmap, QNAS and IQE are said to be weighing pilot production with various foundries and other collaborators. If you could cherry pick the best quality of DRAM and NAND, in case you haven't been following the ultra-RAM story, we first covered this new memory technology back in 2022. It boasted of many tantalizing the cake and eat it attraction, DRAM-like speeds, one less femtojoule switching, 4,000 times the durability of the NAND, and non-volatility for up to 1,000 years. The patented tech would be the first memory to exploit a quantum mechanical process called resonant tunneling. QNAS technology. This is a fascinating technology to see in development. However, knowing the journey from a blockbuster white paper to commercial production is long, hard, and winding one. Many thought it was yet another technology we wouldn't hear of again. In September 2023, we had the pleasure of visiting the ultra-RAM labs, which had recently spun off from the Lancaster University to be championed by the QNAS technology. There, we were among the first members of the public to another milestone, a prototype ultra-RAM memory chip in testing. Now, things are getting really exciting with headlining the scaling of the ultra-RAM fabrication process for volume production. Okay. The next one is prisoners Layment reliance on floppy disks for appeal documents, limiting file sizes to 1.44 megabyte. Prisoners allowed 20 floppy disks in cell, but USB flash sticks are banned in the New Jersey system. Each prisoner is allowed 20 floppy disks, but flash drives are verboten. As when you purchase. Okay, prisoners a prisoner incarcerated in the New Jersey State Prison has written about the trial and tribulations of corresponding with his legal representing is while being shackled by the ancient computer technology, namely floppy diskette, as George Louis Alvarado, writing for PIP, Prison Journalism Production, said it difficult to keep abreast of development in his case due to a prison-imposed digital divide, and Alvarado's lawyers send documents on a flash drive, which must be decanted to sometimes multiple floppy disks on a special computer in the law library. Getting library computer access to take days and time to be crucial during legal appeals. The prison allows the inmate to have up to 20 floppy disks in their cells, but no flash drives. Inside the New Jersey State Prison, it's like 1985, where we rely on out-of-date word processors, electric type wires, and floppy disks that are going extinct in the free world. Lament Alvarado, in his opinion, Pierce, recently published by the PJP. While we can understand why the prison don't have the latest computer technologies at the disposal of every inmate, the preference for floppy disks over the flash drives seems kind of arbitrary. We'd say that the general public's use of the USB flash drive technology became the mainstream 20 years ago. Their ascenders neatly across the over-removal of the Humper drive, floppy drive as a standard component of pre-built PC. Moreover, any advantage USB flash drive had over floppies 20 years ago have scaled dizzyingly your height of the usability. Now flash drives are faster, more capacious, and extremely affordable. They are even sold in multi-packs, not quite up to a common 50 times or 100 times pack like floppy disks, but people don't need so many. Capacity and reliability ooze. Alvarado underlines the issue with floppy disks in 2025 from his option, a personal point of view. A single legal brief can easily take up the memory of the two floppy disks. In compliance. Remember, PC had HD floppy disk capacity was up to 1.44 megabyte. For better capacity remove over the floppy era, you'd have to invest in more expensive media like a zip disks or Syncast. The great home PC CD write boom would occur around the year 2000. Another is Alvarado to have the profits that floppy disks also get corrupted easily. Lessons around that hard way to the main prisoner will need to make backups among their limited floppy disk supplies. The PJP author also noted that floppies are inherently circling the plug hole as no company has been producing new media since 2011. Instead, Sony shut down each floppy production lines in that year. Some will argue that the prison shouldn't have all the latest computer technology available to inmates. However, that has to be balanced by allowing those behind bars sufficient resources to advocate for their freedom. Some studies suggested that between 4 and 6% of those incarcerated in the U.S. prisons are innocent. The next one is Cadence. NVIDIA upgraded pre-silicon power modeling for the big AI chip. Developed in the joint effort with NVIDIA Cadence Dynamic Power Analysis DPA tool will assist engineers in creating more energy-efficient hardware. The massive complexity and the computational need of today's most advanced AI chips will pose a big challenge for designers. They are often unable to accurately predict their power consumption under realistic conditions. To address that, Cadence introduced a dynamic power analysis DPA tool that enables more precise power analysis of high-performance chips, particularly GPUs and other big AI chips. Before the physical silicon is ready, Cadence said a DPA app, developed through a close collaboration with NVIDIA, runs on a TOPICH Palladium G3 hardware emulation platform to evaluate the dynamic power consumption of the chip designs with billions of Ks. The DPA can handle billions of cycles in hours instead of days with up to 97% accuracy. The ED giant said the innovation allows chip designers and and system designers to address power issues before the fabrication of final chip, resulting in more efficient hardware while accelerating time to market. The NVIDIA VP of the hardware engineering, Narendra Konda, said, by combining NVIDIA's accelerated computing expertise with Cadence EDA leadership, we are advancing the hardware accelerated power profiling to enable more precise efficiency in accelerated computing platforms. While predicting power behavior is getting harder for AI chips, the collaboration comes with the latest AI training chips become increasing the power hungry. These chips can obtain $100 billion or more transistor based on advanced nodes like 4 nanometer and 3 nanometer. That's why these transistors each sacrifice a relatively small amount of the current during the operation. The power quickly adds up, and although the supply voltage of the transistor is as low as 0.7 volt, the chips can run though more than 1000 ampere or even 150 ampere of the concurrent, putting the continuous power, also called the thermal design power of the TDP, at over 1000 watt. High-performance GPUs such as NVIDIA's Blackwell, the B100 and the B200 consumed as much as 1200 watt to take care of the computation-intensive jobs such as AI training and a lesser extent, inferencing the things that trending up with NVIDIA's next generation Rubin GPU, which is estimated to consume the 700 watt per 3 nanometer accelerator die. The multi-die Rubin GPU could use 1800 watt when surrounded by the high bandwidth memory HBM. The Rubin Ultra, which will double the number of chiplets, could have a TDP over 3600 watt. Cadence is primarily known for its electronic design automation EDA tools, which are employed by the companies such as AMD, Apple, Intel, and NVIDIA to aid in the development of the next generation chips. But it's also a hardware vendor supplying platforms such as Palladium that emulate these designs and enable engineers to see how they are performed and how much power they draw while running real workload. By enabling the silicon verification and validation, hardware evaluation helps companies deliver a product to market at a faster pace and of cadence. According to the NVIDIA, it's known that these tools for pre-silicon verification and validation of each Blackwell family of AI chips, and the company is utilizing the latest generation by Palladium G3 for some of the future processor design like Rubin. In the context of the pre-silicon verification and validation, having timely and accurate power estimation for actual workload enables engineers to redesign and lowly optimize hardware software to strike the best balance of the power and performance, said Michael Leung, director of the product market at Cadence. But accurately projecting the power consumption of AI chips such as Blackwell is becoming more difficult technically, and this is due to the challenging of the modeling power as smaller transistors are packed more closely. These ultra-dense chips designed to make it inherently harder to predict power under dynamic conditions. In addition, AI workloads have a highly variable power characteristics, straining different parts of the chip at different times. Given that it's important to emulate the entire chip over as many cycles as possible. There are also practical reasons. Under tightening deadlines, engineers rarely have time to perform full chip dynamic power analysis across billions of cycles. This frequently leads to discrepancies between the pre-silicon and post-silicon power dissipation. Dynamic power analysis closing the pre versus post-silicon gap. Traditional power analysis tools struggle to scale up to more than several hundred of thousand cycles without requiring a practical amount of time. According to the cadence in the past, the users could do small slices of power estimation window in hundreds or thousands of cycles, which limited the power profiling the view and hence the accuracy of the real power used to use a particular workload, noted Liang. The company worked closely with NVIDIA to overcome these challenges using the hardware-assisted power acceleration and parallel processing innovations enables more fine-grained power analysis to Palladium. We now have the ability to measure the power estimation of a large workload at length with billions of cycles instead of human thousands of cycles, which was a practical limitation in the past due to the time it takes to process, said Yang. He added that a DPA can more accurately estimate the power consumption under real-world workloads of allowing the power and performed to be verified before being locked into silicon, when the chip design can still be optimized, particularly useful for power-hungry GPU and other AI accelerators. The early power modeling helps to improve efficiency while preventing delays that come from the over-designing under-designing them. In context of pre-silicon validation, engineers can gain a very accurate power data, stated Yang. This allows engineers to rethink what could be optimized while silicon design is still the pre-silicon stage. It also integrated into cadence analysis and implementation solution that designers can do power estimation, reduction, and sign-off throughout the design process, giving you more energy efficient and easier to cool silicon. As the data centers blow up, even though the more electricity accurately predicting the chip level power consumption is becoming the bigger deal, while the power density set servers are pushing more than 3 kilowatt, rack level requirements are also scaling rapidly from 30 to 40 kilowatt today to more than 120 kilowatt for a single rack, equivalent with NVIDIA's Grace Blackwell super chips. Underestimating the power doesn't just risk inefficiently, it could also lead to overriding the power supply or cause thermal failure in other parts. With advanced AI ML type of designs, the need to fully emulate the entire silicon design with a realistic ML workloads is at the heart of the system validation, said Yang. As Palladium DPA adds the extra power dimension into functional validation by evaluating the hardware and software at the same time and factoring them both into a power profile, so Palladium gives the engineers a more accurate model of the silicon validation. Okay, next one is Elon Musk doubles down goal of the 50 million H100 equivalent GPUs in next 5 years and envisions billions of GPUs in the future as Grok 2.5 goes open source. Eventually, billions. Artificial intelligence has been the flavor of the month ever since ChatGPT ushered in a new big bang for Silicon Valley. The big players involved in this race now are gunning for a ridiculously dense GPU cluster that scale AI operation rapidly. One of those players is Elon Musk, who owns X, and next to its namesake xAI, which seems determined to one-up Sam Altman and OpenAI, which Musk, incidentally enough, co-founded. Last month, Titula investor said that xAI will use 50 million H100 equivalent GPUs in the coming 5 years, and yesterday he reiterated that goal. What is this? The old post, but for those that are wondering about what xAI will be up to over the next few years, let's just say that he will be busy. The XAI goal is 50 million in units of the H100 equivalent AI compute, but much better power efficiency outlined within 5 years. It's important to note that how Musk specifically says the H100 equivalent AI compute because they mentioned his version of the 50 million GPUs offering that kind of the power is better, really more efficient. Right now, NVIDIA's Blackwell-based B200 GPUs are the most efficient AI accelerator on the market, but Musk's wording could suggest XAI will move away from the NVIDIA in the future. This could mean a pivot to the AMD, or the XAI developed its own accelerator with a partner like Broadcom, which already designed custom ASICs for others. Yesterday's reply is simple, doubling down this goal, but more instinctively, Musk teases the AI compute at a magnitude not conceived yet by the saying eventually billions. That implies AI will one day have enough power to match billions of H100 GPUs. Of course, this sounds like a bit disconnected from the reality, considering how AI is already perpetuating the environmental risks and these large data centers are constantly affecting the local population. There are also thermal and electrical requirements to consider. Okay, having thought about it some more, I think 50 billion H100 equivalent number in 5 years is about right. The Andrea Jacobson older poster. Okay, across the pond, Musk's role for Musk foil. Sam Altman has highlighted his own mission of a million H100 GPUs by year end, along with the vision of bringing 100 million GPUs online by some point. This is going to require as much money as the entire GDP of the UK. In comparison, at the amount, XAI is operating with around 200,000 H1200 GPUs, significantly short of the 10 billion per year based on 50/5 that Musk wants. Meta is another competitor in this league, and its head honcho Mark Zuckerberg shares a similar vision. He's building a Hyperion data center that are almost as big as Manhattan's will consume up to 5 gigawatts of power, which is nearly equal to the NYC's base electrical load. In terms of actual compute, Zuckerberg has also promised to break the million of AI GPUs barrier by the end of this year. But more importantly, the company is on the cusp of developing a homegrown chip that would end its reliance from foreign manufacturers. All of this comes at the same time as XAI's older model, Grok 2.5, has been made open source. X used Grok 2.5 before it shipped to the Grok 3, which Musk also said it'd go open source in 6 months. Jury is still out on Grok 4, though, as the AI has been recently dodged in a wave of controversy and isn't exactly enjoying the best reputation right now. Sure, some bad actors will be itching to get their hands on this tech, but we can only hope that the hundreds of millions Mr. Musk is planning to spend on expanding his AI clusters can produce a bot that doesn't call itself Mecha Hitler. The next one is the U.S. government planning to take a 1% stake in Intel in return for a CHIPS Act money as SoftBank invested $2 billion. The news last week that the U.S. government might invest in Intel, which lifted the company's share by 8%, has been modified by government officials telling the Bloomberg that investment could be affected by the government converting the $10.9 billion Intel is getting in CHIPS Act grants and military contract into equity. With 10% of the Intel worth around $10.5 billion, the government money would cover the value of the investment. Intel shares fell 3% on the Bloomberg story. However, they rose 5% after hours trading when SoftBank agreed to buy $2 billion worth of the Intel shares at $23 a piece, which was seen as a bet on the Intel recovery. It's being said that the process of converting the CHIPS Act grant into equity could be applied to other recipients of the CHIPS Act funds. And the benefit for Intel of the grant for equity approach could be that Intel gets the CHIPS Act money in its entire quite soon instead of an installment as it meets agreed targets its turnaround project. In January, Intel has only received $2.2 billion out of the total $10.9 billion. The news of the possible grant for equity arrangement suggests that a partnership envisaged between the government and Intel is limited rather than open-ended support. The government would become Intel's biggest shareholder. SoftBank's $2 billion investment makes it Intel's sixth biggest investor. The strategic investment reflects our belief that the semiconductor manufacturing supply will further expand in the United States, with Intel playing a critical role, said SoftBank Group CEO and Chair Masayoshi Son. Intel CEO Lip-Bu Tan said SoftBank and Son share our commitment to advancing U.S. technology and manufacturing leadership, and I appreciate the confidence he has placed in Intel with this investment. Okay. The next one is China mandated domestic funds source 50% of the chips from the Chinese producer. Beijing continues to squeeze the company's over reliance on a foreign semiconductor. Question remains about how the native chips will work with the existing AI infrastructure and software platform like CUDA. I think I read it already. China has mandated all domestic data centers to begin using the more Chinese-produced processors as part of the increasing initiative to make self-sufficient when it comes to the silicon export by the SCMP. This comes at a time with enormous global investment in data center, AI, and processor production, with the increased drive towards self-sufficiency and the data center still stands in the cutting-edge technology. Moving forward, the publicly owned Chinese data center firms will reported to be required to be sourced more than 50% of their chips from the domestic producers, according to the people said to be familiar with the matter. This comes from guidelines initially published last March by the Shanghai municipality. This order appears to have now been extended to the wider country and could have a large impact on the China's chip adoption and investment, as well as the country's overall interest in U.S. producers. U.S. companies like NVIDIA and AMD have further hurdles to selling their latest chips to Chinese firms for some time and are currently only able to sell watered-down version of their latest design, and all while giving the U.S. government a 15% cut of any proceeds per terms of the latest White House deal. Although it seems that the U.S. government does want to maintain the favorable trading relations with China and its domestic companies. The process has fought with the turbulence in recent months, raising concerns that companies unable to source the chips they needed would turn to the other avenue to acquire them. That led to smuggling. Also made the part of the drive toward more local chips production in China. Like NVIDIA or other U.S. companies' initiatives to spend hundreds of billions of dollars in data centers construction and U.S.-based chip fabrication. As China has also announced a plethora of new data center projects in the past 2 years. And of these were expected to be powered by some version of the latest CPUs from NVIDIA and similar companies. However, amidst again, the trade blockades and Chinese concern over tracking hardware built into the graphic cards, it's looking to drive more investment into locally produced chips moving forward. The news followed the report last week, and China was discouraging the use of the product of like NVIDIA's H20, hinting at security concern. And the result of this policy may be slow down the China's AI innovation, though. While locally produced chips are said to be capable enough for the AI inference, day-to-day their operation of learning the AI, but they aren't capable of the latest NVIDIA and and AMD GPUs for training, limited access